Joe Kunches is a space scientist at the U.S. National Oceanic and Atmospheric Administration Space Weather Prediction Center. A former lead forecaster and operations chief, he now concerns himself with issues that directly affect the users of space weather services. Joe is secretary of the International Space Environment Service, a consortium of the European Space Agency and 12 nations. He is a member of the editorial advisory board of the quarterly science journal GPS Solutions. He is also a member of the American Geophysical Union, the U.S. Institute of Navigation, and the International Loran Association. He earned a B.S. in Aerospace Engineering from the University of Notre Dame and an M.B.S. from the University of Colorado in Boulder. In 1973, as an officer in the NOAA Commissioned Officer Corps, Joe was assigned to work in the Skylab program at NASA's Johnson Space Center in Houston. His assignment, which involved conducting observations of solar eruptions, began a long career studying the sun. 4 solar cycles later, he is still at it. Joe Kunches, welcome to the Global Freedom Report.
Thank you, Brent.
And how long is a solar cycle? 4 cycles.
Well, a solar cycle is on average about 11 years long. The sun gives and takes magnetic field and sunspots, and there's a record of a couple hundred years of watching the sun have no sunspots and then emerge to have many, and then it goes back to very little again. And on average, that's about 11 years long.
So we're talking 4 solar cycles, about 44 years. You've been at this for some time now.
Yeah, you'd think I'd know more about it than I do.
Well, you have a degree in aerospace engineering, so you really are a rocket scientist. I mean, when they say it would take a rocket scientist to solve this or figure out that problem, they're speaking about you. How does that make you feel?
Well, I guess it's very flattering, but I think the moral, not just in watching the sun, but in any sort of scientific endeavor, is you don't want to get too big-headed about the whole thing, because we always get surprises, but it's it is the case that as you study anything, and in my case I study the sun and I watch it as we try to predict and characterize its eruptive behavior, to do it the way our brethren in the Weather Service do it, is you try to forecast that activity and give people a heads up as best you can.
Well, just so you know, folks, this is your opportunity to speak with a rocket scientist. 888-747-1968. Seriously, though, your bio states that you concern yourself with issues that affect the users of space weather services. What exactly does that mean? What are space weather services and who uses them?
Well, just the first part of the question, think of terrestrial weather services. Think of weather forecasts. Think of warnings and alerts and watches of bad weather, perhaps, windy weather, hurricanes, tornadoes, and such. Well, it turns out that over time there's been enough development in technologies that have some soft spot or some vulnerability to what the sun does. And the services that my center, the Space Weather Prediction Center, provides are very akin to what the National Weather Service or other meteorological agencies around the world would provide their users. We try to tell them what's going on, and we try to predict what's to occur. And then in my area, it's a little more of an acute problem, because no one has to explain, I think, to any human being if a hurricane is going to be nearby, what the possible effects of that might be. But in my case, if I tell you a solar radiation storm is imminent or a geomagnetic storm, very often the next question that comes back to me and to my organization is, well, what does that mean to me?
Well, and yes, that's why I say who uses the space weather services, because I turn on the TV, I look at the Weather Channel because I want to know if it's going to rain. Okay, but who checks the space weather?
Well, just in broad categories, satellite operators check for space weather, because satellites obviously fly high up in the atmosphere. Many of them have little protection to the charged particles that come from the sun when it erupts, and they would perhaps adjust their operating procedures to be a little more conservative when there's a period of eruptive space weather. Commercial airlines now, as they fly from North America to Asia and back, have found that if they can fly straight over the North Pole, they can save a lot of jet fuel and they can make the trip a little more quickly, especially in our winter months when you have very strong headwinds that typically blow against some of those routes. And they know that to fly over the North Pole causes them to think about communication, navigation, and even radiation issues.
Let's talk about space storms. First and foremost, what are they? What's a space storm?
Well, that's kind of a, believe it or not, a bit of a broad term, Brent. Typically what it is the sun. Again, the sun is a magnetized star, and over time through the solar cycle, it builds up magnetic field that would sooner or later want to erupt. By that I mean go back to a state of lower energy. And for centuries, we knew of these strong magnetic fields because we could see the sunspots that are markers of those. But a space storm usually starts with some sort of an eruption at the sun. We know about it very quickly in 8 minutes when the light from the eruption is seen at Earth, and that's called a solar flare. And then very often there'll be more to it than that. There'll be actually a plasma cloud, which will be part of the outer solar atmosphere that will also get blown off. Those are a little more leisurely in their travel. They go at about 1 million miles an hour, and it's about 93 million miles, so you can do the math in your head. But they take a few days usually to arrive, and the net effect of both the flare and the coronal mass ejection is that a great amount of extra energy is inputted into the Earth's magnetic field. And to continue the train on down through the atmosphere, so what? Well, the Earth's magnetic field becomes very disturbed. The good part is that the auroras, both in the northern and southern hemisphere, both brighten and they actually move more equatorward as the Earth system tries to adjust to this energy. There is a connection between the upper part of the atmosphere and the lower part of the atmosphere where radio waves and shortwave radio is reflected and transionospheric radio. In other words, GPS-like transmissions have to plow through that stuff, and they can get disturbed as that intermediate layer is more turbulent and irregular. And finally, down closer to the ground, power grids and power systems may find unwanted induced currents showing up in their power grids because a changing magnetic field induces a current, and the Earth's magnetic field, as I said a minute ago, becomes very disturbed and very changeable.
When you get hit with a thunderstorm, generally speaking, the storm comes and then it goes. And you can tell because the rain gets heavier and then the rain gets lighter and then ultimately stops. Is that kind of like the progression of a space storm, or is it something completely different?
No, I think that's a good parallel. The time scales might be a little different. A typical geomagnetic storm would last probably a day, maybe 2 days sometimes, so it'll be a pretty lengthy thunderstorm, but it is the case that it comes out of a normal condition. The activity accelerates for a while, it becomes its most intense, and then it goes away, it wanes over time.
Now, earlier you mentioned that a solar cycle was about 11 years or so on the average. And frankly, I've heard about solar cycles. I think most people have heard or read it in the news or something over the last decade or so, perhaps even more so than before then. But what actually constitutes a solar cycle? I understand it takes about 11 years to happen, but what is a cycle? The beginning, the middle, the end? What exactly is a solar cycle?
Okay, I think a good way to think of it is think of it like a season. Think of it like the winter season or the summer season or whatever your favorite season might be. Literally, the solar cycle paradigm or idea began as people, again, as astronomers over the last few hundred years, going back to Galileo and his contemporaries, actually watched the emergence of sunspots as they would become more profligate and more numerous on the surface of the sun. And if you were patient and you had some pretty good weather where you lived and the clouds didn't get in the way too much, you could actually watch a season begin with no sunspots visible on a day like today, and then maybe a year from now you would see a handful, and maybe a year after that you'd see 20, and so on until maybe it would be more like 3 or 4 years into the season the maximum number of sunspots would be seen, and then over time, and it's a little longer of a calming or a decay phase, those sunspot counts would diminish and they'd go back to near zero, and that's what we would term a solar cycle.
How often does the sun issue coronal mass ejections, and what is the likelihood? Now, I'm a big science fiction reader, okay, so I know enough to be dangerous on issues like this. What's the likelihood that a CME could be launched on a direct collision course with Earth, and if such a thing happened, what would it mean for Earth's climates and for Earth's technological infrastructure?
Well, that's a good question. The first part is during solar minimum, the period we're just coming out of, and I should tell you, we're at the beginning of the new season. Solar cycle 24 has just begun, and we say that because we pay attention to the sunspots, and we've seen those counts start to increase.
Does that number just from the time we started counting cycles? Because at 11 years, 24 cycles is only 264 years.
Yeah, that's right. So, I mean, it's called the modern record of sunspot observations. In the literature, it's said that the Chinese actually were counting sunspots thousands of years ago, and but I think there's a pretty good parallel between the type of star our sun is and other similar stars and this 11-year marker. Again, it's an average number. Those cycle lengths can vary from, say, 9 or 10 years to 13 or 14 years. But asking about coronal mass ejections, on Valentine's Day, right around Valentine's Day, about 2 months ago, there was actually a chain of 3 of them that were launched from the sun, from an active region, which was positioned, right down Main Street, as it were, directly facing the Earth, that did pass the Earth, and they did cause a very fairly low level of geomagnetic storming, but it happens. I mean, you can imagine the sun doesn't give a hoot really about where we are. It goes about its business. It goes about the physical processes that it's used to doing, which is making magnetic field and shedding magnetic field. And every now and then we get in the way of one of these coronal mass ejections, and those are really the main things that initiate the strongest geomagnetic storms.
Does solar activity have any effect on other stellar objects? We've been told we have asteroids that are catastrophic size that are heading for Earth. I think 2029 is one of them. Can sunstorms or space storms in any way alter the course of such objects, either to our benefit or to our detriment?